Okay, so question 1F. The turning point of the parabola y equals x squared minus 2ax plus 1 is closest to origin when for some condition of a. Okay, so how can we figure out the turning point? Okay, we always complete the square, right? So let's try to complete the square. That will be x minus a all squared, yeah, because that's 2a, so we make it into a. And then plus 1, which is that. Now note that the a squared is extra. Yeah, so we have to subtract x squared to balance the equation. Okay, so now that's the completed square form of the parabola. So now we could easily read that the turning point, let's say TP, would be a and 1 minus a squared. Yeah, by just reading the completed the square form of the parabola. So this turning point is closest to origin. Now, what does closest mean? Closest basically means like the smallest distance, right? So if we could find an expression for the distance, and then find the smallest, then that would be fine. So what would be the expression for the distance for this point compared to the origin? Well, we use the distance formula, right? So the distance, let's say d, would be a squared plus 1 minus a squared all squared. Yeah, and what would that be? That means that would be square roots of a squared plus 1 minus 2a squared plus a to the 4. Okay, and we further simplify that into a to the 4 plus a squared plus 1. Okay, now the question is, how could I find the closest point? Yeah, we want to find the minimum, right? So firstly, the square root really does not matter. Okay, why is that? Because if the thing inside is small, like if it's the minimum, then if you square root it, it's also a minimum. Yeah, because square root is an increasing function after all. So it really doesn't matter if the square root is there or not. Okay, so do not try to differentiate the thing. Okay, that would take you ages, and it's just you should get the right answer, but there's really just no point. All right, so let's try to complete the square. Now, let's say this is a parabola in terms of a squared. Okay, in terms of a squared. Now, how could I complete the square then? So this one is a squared squared, basically, right? So if I write it in a more formal way. So a squared plus 1/2, yeah, because the coefficient here is 1, right? So I have to divide the coefficient by 2. So that's a squared plus 1/2 squared plus 1 minus 1/4. Yeah, because the quarter comes from the 1/2 squared. Okay, so you know that this parabola has a minimum point at where? The minimum occurs at a squared equals minus a half. Right? Okay, I think I've made a mistake with the signs here, sorry. So that's minus a squared instead, and that should be minus a half. Alright, so yeah, so that should be a plus a half, which makes much more sense. Okay, so a squared equals 1/2. Okay, that's how we find a minimum. Yeah? So a would be equal to plus or minus 1 on root 2 by the square rooting both sides. Okay, do not forget the plus or minus, alright? Yeah, cool. So that's basically how we solve the problem. So now let's look back at the question. So a, b, c, d, which one is it? It would be d. Yeah, a equals plus or minus 1 on root 2. Okay, cool. So that's the answer.